just for making sure that you are in the right session. So this is the session, Cloudfire and SUSE, the secret sauce to manage more than 1,000 devices. It's a worldwide deployment. We are going to present to you a real customer use case. And so let's kick it off. This is the agenda for the session. A quick introductions from me and Fabio. Then we will introduce SUSE Edge for manufacturing. What is the solution that SUSE offers for the manufacturing challenges? As well, introducing the customer use case, really interesting. So I will hand over to Fabio to introduce the use case, the challenges, the solution that Fabio and the customer and SUSE built together. Why SUSE Edge for sure? So this is really important. What were the problems that we solve? How we improve the customer business with this solution? And then the next steps, really important. So the roadmap for adding more services or scaling the current deployment. With that, let's start. So who are these two presenters? My name is Carlos Torres, based in Milan, Italy. I'm working for the EMEA region, and my role is sales specialist for edge computing. I'm responsible to support customers, prospects, working together with strong partners like Cloudfire in providing solutions for edge computing. And Fabio.
Yes, my name is Fabio. I'm the CTO in Cloudfire, and Cloudfire is a cloud provider, an Italian cloud provider. And of course, all the technologies of Cloudfire is my mention. Okay.
Awesome. Let's move on. Now, SUSE Edge in manufacturing. Manufacturing for us in the Edge organization is a key focus industry. We are going to see where SUSE fits in manufacturing. So probably I met already a few of you, so you are not coming from the manufacturing industry. But what is really important to understand is the challenges that we have in this industry, right? So this is the Purdue model, right? So it's a model from 90s, more or less. And this model provides a framework that describes how industrial control systems are deployed, maintained, and how you need to protect these control systems, right? And we have in this Purdue model, we can see that there is a hierarchical communication where there are dependencies between the different levels, where the upper levels control the lower levels. As well, we see that there is communication that is allowed only from the lower levels to the upper levels, just outbound communication. Inbound communication is allowed only for control systems. So this is another challenge. So how SUSE is going to modernize this complex framework, right? So we see in the level 3, if you are familiar with edge manufacturing, there is a common word, AT/OT convergence, right? So in level 3, we see a lot of modernization of applications in the level 3, because this is the level where there is huge IT technology adoption in regards of applications that are responsible for manufacturing planning and operations. And we see applications like manufacturing execution systems that providing KPIs, performance indicators for the production plants, like OEE, overall equipment efficiency. And we see the adoption of IoT platforms, right? Platforms that are gathering data from SCADA systems, platforms that are introducing new use cases, analyzing data for use cases like predictive maintenance, real-time conditioning monitoring, digital twins, and more. And in the upper levels, we have the classic IT levels, right? ERP and cloud services. Now, where SUSE fits in this manufacturing Purdue model, right? So as I said before, communication in this model is highly regulated, right? So only outbound communication, only outbound data is allowed between the lower layers to the upper levels, right? In this case, we see a lot of modernization, as I said before, in the level 3, where we already see Kubernetes, cluster Kubernetes adoption, microservices, and there is a need to deploy and maintain those Kubernetes clusters. And based on the information that is allowed, just outbound, we see that Rancher can solve this kind of challenge of the communication and can be compliant with this complex model because Rancher is very lightweight and designed for edge, right? You can put in the plant DM seat a forward proxy and you can allow communication from the Kubernetes clusters in the level 3, in the level 2, all the way out to up to the data center and the cloud. But what we are offering in Rancher Suite, Rancher Prime, so we are offering a full stack that is purpose-built to manage and to address all the use cases around edge in manufacturing. Starting from the operating system, this stack includes SUSE Linux Micro with specific features for edge, like Edge Image Builder, and probably you met my colleagues in the booths, brilliant colleagues, technical marketing team, engineers, so I really recommend to, if you have any requirement or any clarification, you can meet those guys because they are super available to explain you more. So Edge Image Builder is providing the feature that Fabio is going to explain, how we are adopting Edge Image Builder to create those images that are going to be immutable, that are going to introduce features, really important features for highly regulated industry like transactional, right? Then we provide as well SUSE Multi-Linux Manager because we know that in this kind of use cases, there is still huge presence of Linux, right? So customers can improve the way that they manage Linux system with SUSE Multi-Linux Manager. But when it comes to Kubernetes, we are including in the solution Kubernetes engine in 2 flavors, RK2, K3S. And this is really strong because you can deploy K3S, single node, very lightweight deployment. We have seen a lot of industries like manufacturing, energy, and oil and gas that are adopting more and more K3S. They can start with a single node. They can scale even to a cluster. So it's a really flexible, lightweight solution. And then on top, we have Rancher Prime that is taking care of the management and the life cycle of this platform. Now, probably you already joined other sessions from my colleagues from Rancher. So we are including in Edge Suite the same infrastructure services that is already included as well in Rancher Suite, right? We are talking about observability, really important. So, and especially when you have these distributed large deployments in Edge, it's really important to have observability, making sure that your clusters are operating in the right way. We are providing storage as well for persistent applications. We are providing security in the solution, new vector, so for making sure that the communication between pods and containers is secure, and app collection as well for providing security in terms of software supply chain, because this industry, manufacturing, and other industries, energy, oil and gas, are highly regulated. So they need to be compliant with software supply chain and other security standards. So this solution is purpose-built for edge computing. So it can overcome challenges, common challenges in the edge. It can work partially connected, disconnected. It can operate in very lightweight systems or as well in a big cluster. And we are going to see what could be the journey and the approach, right? So what we see is for customers that are running Linux workloads, the solution includes the tools for improving the management of those Linux devices. But as well, the solution includes the tools for modernizing in an additive approach. What does it mean? It means that in manufacturing, you cannot change the systems, the core process systems, but you need to have an additive approach. So you can modernize existing systems, existing infrastructure in a layered way, we can integrate our solution in third-party Linux, we can modernize, and we can provide a full stack. So we are providing a full stack solution with additive approach for moving from Linux to cloud native, edge, and as well introducing AI use cases. In terms of compute capacity, it means that this solution can address industrial IoT devices or gateways, devices that they have on board GPUs for inference or real-time monitoring. They can scale to more high-density compute devices, servers for data aggregation, analytics, inferencing, as well as we can provide a full-stack solution that includes the infrastructure. So we have customers in the automotive space that are using distributed and small data centers in their plants, where they are leveraging SUSE virtualization as an infrastructure as a service, so they are consuming infrastructure as a service for SUSE virtualization. And on top of SUSE virtualization, they are building their Kubernetes clusters. With that, I will hand over to Fabio for introducing the customer use case. Thank you.
Thank you, Carlos. Our customers, we are under NDA, so I can say the name of customer, but our customer is an Italian company, and there are not so many Italian companies that build automated storage and ceramic digital printers, so if you can search a little bit, you can find it. What is the project? It's to provide those devices that are, for example, oven of 100 feet of length, all around the world. So even in some countries where, for example, the regulation about data is not so easy. Okay, so we start with Italy for a small POC, and a small POC, it's a big number, and then we scaled to EMEA for the first phase, and after that we extend for all the globe. So, okay, so the main challenges for us was that the POC is not so small, okay, are hundreds of devices, and for productions, for the very next 3 years, we can achieve about 10,000 devices, and of course they will be geographically distributed. So our customers need to ask us to use Rancher to manage the entire IoT supply chain. And what does it mean? Our customers built the board, the device, that is an x86 platform with 32 gigabytes of RAM and different scenarios for the storage, okay? Because in some models they have just 100 gigabytes of storage, and in others they have terabytes of storage. And they need to start from the empty custom hardware to the fully managed device using just Rancher and all the ecosystems, I mean. And of course, Kubernetes used for the abstraction layer, for the cloud part, and for the IoT part, okay? Our customer is using Pulumi as infrastructure as a code because they don't have any skills on Terraform and other stuff like this, but they need to manage the entire infrastructure, especially in the cloud part, using infrastructure as a code, and of course security from the device perspective, and efficiency. And from one requirement that is from our side is keep it simple and scale out, because the numbers are really big. So what is the solution? I mean, this is the diagram, okay? It's pretty simple. We have Rancher Prime that runs on AWS. And we have, for example, the site A that could be a warehouse or something similar. Site A, sorry, and the site B could be a ceramic. And the proprietary app of the customer is use up to 30 pods. Today was 31, so. And how it works? I mean, obviously they need to interact with a PLC, so, and use some small AI machine learning model, okay, that are computer vision to do the quality check on the same line. And of course, are different models for different use case. And they need to interact with Rancher Prime and push data such as metrics of sensor and actuators, for example. And they need to use just the HTTPS protocol to talk with the cloud. So, okay, so how the device is provisioned? Well, our customer use SL Micro, but they create the image using the image builder and put it on the USB key. So he manually do the first deploy, okay, in their fab, okay. So he sent the device to the final customers, and after that, the OS do call home to the Rancher on cloud, and using Elemental, he can manage the remote operating system and interact with the Rancher agent, and that is, of course, installed with K3S, because on the device they are using K3S. So it's a single node cluster, okay? Okay, the US deploy is it's a manual deploy because continuous integration is okay for our customers, for their customers, sorry, but the continuous deployment is not possible. I mean, the device needs to be 24/7 fully operated, so they cannot update the OS and apps when they want, or without scheduling a maintenance window. So, and the customer initially don't want to use immutable operating system, but we are changing this, so it's not my choice. Okay, and of course, this was the operating system perspective, but inside the K3S cluster runs 31 pods, and how these 31 pods are provisioned. Well, each K3S obviously is a mission critical environment, so CI is okay, but continuous deployment is not possible. So, except for the monitoring part of the device. So we can use Fleet for the day 2 operation. That was the tools that we want to use. And we need to update apps manually using the apps section inside the Rancher dashboard. Because pods are, applications are deployed using Helm chart. So, okay. And okay, how each site interacts with the cloud Rancher? Well, we need to use HTTPS. We can't use any other protocol. And obviously, we have a Rancher agent that talks with Rancher through HTTPS, so it's okay. But we need to collect some metrics, logs, and traces also through the HTTPS. Okay, this is not a big deal. The third scenario is pretty complicated. Okay, obviously we worked together with our customer to how can I say, encapsulate MQTT traffic inside HTTPS and send to the Rancher cluster. And okay, the application of our customers collect all the information from the device to create a digital twin in cloud. So the main goal is to predict the failure of the device, upload the data to the cloud to digital twin, and is useful also because they are running some machine learning stuff on data, so they can simulate and predict failure in a better way. And of course, they need to test some patches, update, and they need to do it on the digital twin, so it's like a stage environment for them. And of course, from the customer care perspective, they can operate on the digital twin to simulate everything and try to reproduce different ways to solve issues in case before they, how can I say, they touch the real environment. Okay. And what about observability? Okay, we are using the SUSE observability for the device. For the platform. Okay, for the K3S and all the pods. But for the actuators and for the sensors, we need to use something else. So our customers want to use Prometheus, Elasticsearch, Prometheus, Grafana Loki, and Jaeger for tracing for their apps. So this device could be offline for days or weeks, okay? But we need to collect metrics and store them locally, so we need some spaces. And of course, we can, typically we have 3-day retention on the local device. After that, all the metrics and logs and traces are offloaded to the cloud cluster. And in this way, we can centralize all the stuff related to observability. From the security perspective, okay, we are using NeoVector, but some final customer ask to our customer, that obviously asked to us, to do, how can I say, to do something that is not so common. I mean, for some company, the offloading data through cloud is like a data breach, okay? So they need to inspect traffic and they need to do a sort of man in the middle because everything is HTTPS. So they need to read the traffic and then check that everything is okay and then push it to the cloud. So how can we solve this problem? Well, the first approach was, okay, we tolerate the man in the middle in this case, but we change it and we mirrored traffic on the second network interface. So the final customer can receive all the traffic and inspect all the traffic, and in the same time, the same traffic goes to cloud. So, okay, well, NeoVector is used to manage the all the devices that are globally distributed from a single point. So we have just one dashboard that is the NeoVector Cloud dashboard, okay, and we can manage all the devices. And of course, our customer asks us, okay, we have our board and we have a TPM chip on it. So can we use it for the security in some way? And well, maybe. But first, why SUSE Edge? I mean, what is the motivation? I mean, it's just one image worth 1,000 of words, and in this case, 1,000 of painting. I mean, we have a lot of tools that can enable us to manage everything from a single dashboard that is Rancher, so why don't use it? It's simple, it's supported by SUSE, and it's really cool, and it works. So, okay, so what's next? And I'm almost at the end. Well, do you remember the TPM? Okay. We decided to use TPM to validate traffic, okay, but not in the legacy way, where using TPM I can validate the entire device, because we want to split. We want to use TPM to validate each pod, okay. So how can we do it? How can we achieve this goal? Well, using Keylime, that is a CNCF open source project that can do this stuff, okay? Is not production grade right now, and we are doing some R&D with our customer to using this tool. But in 2 words, it's like, okay, in this diagram you can see the Kubernetes control plane and the Kubernetes worker node. But we don't have this scenario. We have K3S, so control plane is the worker node. So, but just use this diagram to understand how it works. We have a Keylime verifier that is a sort of whitelist or blacklist, okay, that can talk with the Keylime agent that will use a TPM chip to validate each pod when the pod is scheduled from the API, from the control plane, and he can invalidate the single pod, so the scheduler can kill the pod that is compromised. So, okay, there are a lot of challenges in this diagram. So, starting from the part of control plane is equal to worker node, we need to move the Keylime verifier on the cloud part. So this is a tricky problem, and we don't have any solutions right now. We are talking with Keylime community to try to add this part. So we are working with the guys, but right now it's just a POC and it's just in R&D. And of course, why not to use this kind of stuff, for example, for SUSE virtualization? I mean, in SUSE virtualization, each pod is a VM with the different that I don't have just a single worker node. I have multiple worker nodes, and my pod can be scheduled on different worker nodes. So I need to whitelist and blacklist pod in real time, okay, in different scenarios, and we are talking with the Keylime to try to extend our vision to in the way that we can use it for SUSE virtualization too, not just in the edge world. And okay, if you have any questions, feel free to ask us. Thank you. Thank you.
No question? Yeah. Hello?
Yeah. On slide 20 or 21, one of those slides, there was SUSE Rancher with the K3S pointing to that. Is that on the cloud, or is that where is that user and customer care connecting to?
Yeah, you're right. Okay, the rancher part is on the cloud, is on AWS, and customer care will connect to the rancher to manage the K3S, that is the device on field. So.
And then I guess the digital twin, is that the
Yeah,
AWS,
the digital twin is on
AWS service?
Yeah, is on AWS. Yeah.
Okay. And then I guess splitting the traffic. Yeah, so
Yeah.
I remember that. Yeah,
Okay,
I was
this
just
one. Okay.
curious. I know that's an AWS service, but you were talking about splitting the traffic, verifying the traffic.
Yeah.
I don't have
in the TPM.
Yeah.
No, I'm sorry.
I don't know if it was a TPM.
Sorry. Yeah. It's just because for some customers, for some final customers, okay, they need to inspect all the traffic because the device is not property of the final customers. It's like how can I say? Yeah, it's rented. Okay, sorry. It's rented. So they need to.
They are aggregating more data from different other customers. So they are providing the technology, the deployment of all the facilities, the industrial gateways. They are feeding the data to AWS, but the end users are other customers, right?
Okay.
Yeah. And they need to inspect the traffic, but okay, it's pretty difficult because if you inspect HTTPS, okay, you invalidate the HTTPS. So. I mean, I'm not able to discriminate if it was a man-in-the-middle attack or it was the final customer.
Yeah.
So.
Okay.
Other questions? Okay, so just for closing, so SUSE is providing a full-stack technology for covering all those customer requirements. And you have seen challenges around security, lifecycle management, data aggregation, deployment from AWS, management, central deployment, central management. And yeah, probably you joined yesterday the keynote. There was a Mitsubishi that was awarded. They received the customer award, really interesting use case. They are moving to software-defined SCADA systems. They are collecting more and more information, moving to Kubernetes. So it's a real value, right? So, and I invite you, if you have any curiosity, to reach out to us. And if you forgot to get the book, we have the Cloud Native Essential book, right? So you will be awarded as well with the book. And yeah, thanks for joining.
Thank you.